In this video, we're looking at intersecting chords and secants theorem. Now, you might be wondering what these things are. So we're going to use a circle and we're going to define some of these objects. So here's our circle. And a secant is a line that goes through the circle just like that. Now, a bit of a secant is actually a chord. And I'll draw another one over here. This thing here would be an example of a chord. So it's kind of like a secant, but it just doesn't keep going past the circle. And we have another one which is called a tangent. So a tangent just touches the circle at a single point. So those are the things we're going to need. So the first one is intersecting chords theorem, and it tells us basically that a few lengths times together equals a few different lengths times together. So let's look at AX and BX. So it would be this length and this length. Let's just say that was like, I don't know, 3 and 8, for example, could be those lengths, equals CX times DX. So this one might be like 6 and 4. And the theorem basically says that when you do 3 times 8, it should give you the same thing as when you do 6 times 4, which it does, because both these are 24. And that's an example of how the theorem will work. And that could be any numbers you want, but when you times them together, they should give you the same thing. Next one, we got the secant tangent theorem, a very similar concept. So if you take this length and you square it, that should be the same thing as if you do XA times XB. So that's times the whole thing. You just got to be really careful, because I think a common misconception would be to use that length there, but you'll never use that length AB. So that's good to know that thing there. So an example of this could be like if this was like 4 and then that was 2 and that was 8 as the total length there. So you'd get 4 squared equals 16, and you'd also get 2 times 8 equals 16, which match. So there's an example for you. Next one we got is secant theorem. So XA times by XB, again, the little one times the whole entire one equals XC times XD, same concept. We have a few corollaries here. So you're able to determine something is a cyclic quadrilateral if it follows this theorem. And if A and B are distinct points on the circle, blah, 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 then you're able to determine whether something is a tangent. So basically it's saying like, these are some properties of tangents and chords and secants and stuff. And if these properties hold, you know something is a tangent. That's our second dot point. Okay, so let's look at these. We should have 3 times 4 equals 5 times x by the, and we got to see the intersecting chords theorem. So this tells us 12 equals 5x, and then all we need to do to solve that is divide out by 5. So x equals 12 over 5, which I think is about 2.4. All right, time for question 2. So what you're probably going to be tempted to do with this one is to do 5 times 7 equals 4 times x, based on the secant theorem down here. Now that is actually wrong, and I'd really encourage you to pause the video and see if you can figure out what is wrong with that based on this theorem down here. Essentially what is wrong with that is that it's 5 times the total length there. And you'll notice because it's XA, which is that length on the theorem, times by the total length of XB. So instead of having 7 there, the total length is actually 12. And instead of having x here, the total length is actually x plus 4. And this is by the secant theorem. Okay, we can simplify down the left-hand side to be 60. And then we're going to have to do something called expansion. Now, you may have seen expansion before, you may have not. We'll delve into it deeper in the quadratics topic later on. But essentially what we need to do is take this 4 here and expand it into both terms. So I'm still going to be left with 60 on the left, and I've got 4x plus 16. Then we can solve this like a normal equation. So you take 16 from both sides. So 60 take 16, it should be 44. And then we get 4x there, just like that. So to keep solving this, we need to divide by 4 on both sides, so we can do that. We're going to be left with over here just x, and we're going to get 44 over 4. But probably the more familiar way to write it is just that x is 44 over 4. So if you're not sure what that is, you can just chuck it into a calculator. So we'll do 44 over 4 here, and then we should get 11. So that's what I'm claiming is true for this one here, x is 11. Now it's actually a really good idea to check that this is correct. So if I do 4 times the total length, which is 15, and 5 times the total length there, which is 12, I should get the same answer, and in this case it's 60 both times, so we know we're on the right track there. And hopefully you can spot here there's something missing in my answer. I did not put units on that length there. Okay, question 3. So we'll just have a look a bit further up here, and it looks like this one is the secant tangent theorem. Now this one actually works really similarly to the secant theorem. It's just that essentially that length there, where it goes through the circle, it's got a length of 0 passing through the circle. Apart from that, the theorems are equivalent. So essentially what we've got to do is we've got to do this length times the whole length. So it's going to be x times that length again, x, and then equals 2 times. Now, I'm going to make a mistake here intentionally. See if you can spot it based on that theorem definition. If not, it's the same mistake I warned you about before. Basically, you've got to have the whole length there, so 7. So this is by the secant tangent theorem. Okay, once we got that, we've got x squared over here, and it's 14. So if we rearrange that equation, x is just going to be square root of 14. Now, very technically, you do get a plus or minus when you rearrange this equation, but x should just be positive root 14 as lengths are positive. So it's good to mention that you've noted that there could be 2 answers, except in this case, it's just the positive one because we're talking about real world lengths. All right, next up, we're just going to get an approximate for this. So x approximately equals, and then we can just do that on a calculator. So we go root 14, and then you can hit this little S to D button here, and you'll get 3.742.